So let's get into the second part, which is switching and VLAN trunk. Those are layer 2 terminologies. Let's get right to it. So when we look back 30 years ago or 40 years ago, we have two devices, hub and the repeater, hub and repeater. These two are the same. Hub just work on the physical layer. That means a hub just replicate the electrical signal. For example, this Fred just send out a package or send out the frame. A hub just replicate this electrical signal and send it out all of the ports. A hub didn't know anything about MAC address and data link terminology. They didn't know any data link. They just replicate or just repeat the electrical signal and send it out. So it is called when the Fred talks, any other else can talk because they share the medium. So we call this sharing, or we call it collision domain because one of them talk, they just leads to a 100% collision. They also share this own bandwidth because the hub and speaker are using 10 base T or 10 base 2, which was a technology for Ethernet 30 years ago. So that's the collision domain is all about. And a bridge is kind of enhanced devices. So a bridge try to separate collision domain. Here we have two collision domain with one bridge in between. So Fred talks, this is their own collision domain. And Wilma and Betty has its own collision domain. So they don't interrupt or Fred and Barney had its own collision domain, and these two had its own collision domain. They don't interfere with each other. That's a bridge. That's a bridge is all about. And be careful here for if Fred wants to talk with Wilma, and the bridge have to have a table, for to know that Wilma is located outside this interface, and Freddie and Barney is located or sitting outside this interface. So that's that's the time that switches comes into play. A switch is a multi-pod bridge. Normally, generally speaking, the bridge only has two pods, as shown in the last slide. But switch is a multi-pod bridge like this. It has 4 ports and 4 collision domain. Because every port only connects to one device. So kind of like there's no collision because it's only one device dominate the whole collision domain. So for this force communication, so switch has to have a address table. We call it the MAC address table. To form or learn MAC address is a switch essential task. And for example, here they just learn all fours MAC address and this interface mapping here. This is pretty MAC address tables essential component for every switch. So after we talked about collision domain, we talk about broadcast domain. So broadcast domain, what it means by that? Just if Fred just send out the broadcast, for example, FFFF, this is the layer 2 broadcast. Broadcast, switch can block layer 2 broadcast, it just send out of all of the interfaces. So every other can see this broadcast message. So we call this a broadcast domain. The broadcast domain also called a LAN. So every LAN is isolated. If you have this line is isolated, you have another line and another bridge. This is isolated broadcast domain. There's two broadcast domains. So that's a switch. Switch can split collision domain and only have a broadcast domain. What about VLAN? So if we want to create multiple LANs, do we have to buy multiple switches? The answer is no. By using these virtual LANs, we can leverage only one physical devices, physical switch to form or to create multiple VLAN or create multiple virtual LANs. So please look at this diagram. And here we have three switches, physical switches, right, connected with each other. And we also have some of the endpoints, which are 6 PCs. And they are sitting on the different VLANs, right? It's VLAN 10, VLAN 20, 30. So they form different LANs. From VLAN point of view, VLAN has many benefits. For example, it just restrain the broadcast domain, right? Because a LAN is a broadcast domain. If we separate all of the endpoints into different VLANs, we create different broadcast domains. So improve security or efficiency, improve IP efficiency. For example, we have different faculty, we have students, we have guests. Those are different management uses. So we can assign different PCs to different LANs for only management. For management, for the ease of the management. And we also have some of the other benefits. So bear in mind, if you have a specific VLAN, generally speaking, you have to assign a distinct IP subnet to this VLAN. So every VLAN had this different subnet for the ease of management. So every VLAN has its own unique IP addressing or IP subnet. So VLAN trunks. as we talked about on this for this diagram, so if we look into communication or paths, for example, VLAN, this guy wants to talk with this guy, PC1 to PC4, which were located in or reside on VLAN 10, and they have to go this way. For VLAN 20, they also go this way. VLAN 30 is go this. So S2 and S1, this link, physical link, is kind of like a shared link. So what is VLAN trunk means? Within this shared physical link, are some virtual channel inside this physical link. We call this trunk. We call this big structure is a trunk and with different VLAN sub-channel. For example, this is VLAN 10, this is VLAN 20, this is VLAN 30. So this kind of structure we call a VLAN trunk. So this physical link need to be a trunk. This physical link needs to be physical trunk for different VLANs to go through, right? That's the VLAN trunk. Definition of the VLAN trunk. And the VLAN trunk has different encapsulation. How to identify this sub-channel? They have different different headers. So industry standard is AO2.1Q, which is and have some proprietary protocols. We just need to remember this AO2.1Q trunking encapsulation, which is enough.